Hello everyone, welcome to the course. In today's lecture, we'll be discussing about JavaScript syntax. We'll be focusing more on modern ES6 syntax. I'll be assuming you know any other language, so we won't be going into every single syntax in detail. Rather, we'll be looking at what makes JavaScript different and discuss language specific ideas. We'll be looking at variables and scoping, what are the different types of primitives, what are the different data types in JavaScript, functions, some asynchronous patterns, and at last, some defensive coding. Let's start off with variable declaration. In JavaScript, we have three different ways to declare variables: let, const, and var. All these three are different in subtle ways, and for developing modern applications, we prefer the use of let and const. Let and const have their behavior very closely related to each other. They have the same block scope. They can't be redeclared in the same scope. For example, if I say let a equal to 10, I can't use let a. The declaration part, I can't use it again in the same scope. And we cannot access them before initialization. Before the initialization, we can't use let and const before the actual initialization. So this thing came up because there's a problem with var. There's a problem with var that there's a problem with var that we can use it, we can access it before the actual line in which we have declared the variable with var. That causes certain issues. We look at it later on, but right now understand that let and const cannot be used before the actual line in which they are declared. The differences between let and const here is let, I can assign it to a different value later on. Like if I'm using let in a for loop, I can say let I equal to 1, later on it can change to 2 and 3 and so on. But const means I can't change the value. I can't reassign the value later at a later point of time. With var, it's a function scoped, it does not care about blocks. So it will creep out of the block in which it has been declared. You have to be very careful with that because generally we expect things to be block scoped. If I'm declaring something in a for loop, I expect it to be scoped inside it. It should not go out. But var does the opposite. It does not care about blocks. It just cares about what function it is declared inside. And we can also reassign var. We can also redeclare var. We can actually access var before initialization. And if we try to use it, the value will be undefined. Here we have an example of using a block. So this if is a block. Any curly braces, if we add, that becomes a block. We have declared variable x with let, variable y with var. So x being declared with let, it does not go out of the block. So the scope is limited to this block only. Var only cares about the function it is declared inside. That means it will go out of the block, and even here if I console.log, it will give me an output. But this will give me a reference error. Since I have declared x with let, I can reassign the value to something else at a later point of time. It does not matter what data type it is, I can reassign it something else. But if I do the same with const, I can't do it because that is the meaning of const. I don't want to change later point of time. If accidentally it changes, it gives me an error. Generally, we try to use const everywhere that we want. Only where we know the values will change, like in a for loop, if I'm using I in a for loop, then that value will change. So in that case, we will use let. Otherwise, most of the variables that we declare, you should use const. Now let's talk about redeclaration. Redeclaration means I declared the variable with let. Then again, I'm trying to declare it again, let x equal to something else. Doesn't matter, it can be anything. I can't use let x again in the same scope because I have declared it once. I can't declare it again. But with var, that's not the case. Var, I can declare it once and I can do it again as many times as you want. Here's an example of var being function scoped. So if you declare var inside a function and I called it, and even after that, so after calling this function, the artist variable, I can't access it because var is only contained inside the function. Even let and const will not creep out of the function. So let and const, you can say let and const will be contained by both the function and a block. var will only be contained by a function. Data types in JavaScript are classified into primitives and objects. Primitives are the smallest piece of data that a programmer can work with. So these are stored as values, as actual values. And these are the types of the primitives: number, string, boolean, undefined, null, symbol, and bigint. We will be mostly concerned about number, string, boolean, undefined, null. Bigint is something if you want to use a larger integer that can't be contained by the normal safe integer size, then we can use bigint. Note that JavaScript does not have a separate integer and float types. They are both contained inside a number. Objects, on the other hand, are stored by reference. So they are stored as pointers to the memory addresses. So as a consequence of that, if you try to copy an object directly by assigning it to another object, they will both point to the same object. So any changes in one object would also be reflected in other object. Objects are collection of key value pairs, basically like dictionaries, but with certain additional functionality, and they can hold multiple data types. We'll look at objects in much more detail in a later point. In JavaScript, even arrays and functions are objects. Functions are special type of objects that can be called using parentheses. So here we can see on the right hand side, we have the primitives, name which is a string, count is active, boolean. When you say let a variable name and not give it a value, by default, the value becomes undefined. So that is also a data type. And we can check what the data type is using the type of operator. Type of is an operator. We can use it to check what the type of data is there. As you can see, when you add the type of name, you get a string. When we had a type of age, you get a number. On the left hand side, we can see the objects. That's an array. That's also a type of object. Internally, function is also an object, although that's a special type of object that is callable. That's why when we get the type of greet, we get a function. Since functions are also objects, they can be passed around like objects, given as parameters to other functions, assigned to variables as well. That's a very good thing that JavaScript allows us to do. Heading over to functions, we have two different ways of declaring functions in JavaScript. One is using the function keyword. Other one has this arrow syntax over here. So this is called the arrow function. This I'll call the normal function, and this is called the arrow functions. We define the normal function using the function keyword and adding a name. With the arrow function, on the other hand, we can do the same thing in a much shorter, concise manner. See how much shorter it is to do this exact same thing. By default, arrow functions don't have a name, so we need to assign them to variables in order to execute it. So we have assigned the const greet, that's a variable, to this arrow function. So using the greet, we can call this arrow function. If you don't have multi-line statements, you can directly return the value, and you can also have brackets over here and do multi-line statements in arrow functions also. Then you would need to use the return statement in order to return whatever you want to return. If you have just one parameter in arrow function, you can skip the parentheses as well. So you can say greet equal to name without the parentheses directly. Here's the key difference between arrow functions and normal functions. Arrow functions don't have their own this. They inherit this from the surrounding context, which is important when we are working with methods or callback functions. We will discuss this in much more detail, so don't worry about that yet. Okay, JavaScript is single-threaded, but a lot of things that we do with JavaScript takes a lot of time, like fetching some data from another server, things from a file, IO operations, and so on. That's where asynchronous programming comes in. We don't want the entire program to freeze when JavaScript is loading some file or waiting for something. Traditionally, we had callbacks. So this is an example of a callback. So this fs is reading a file, which might take a little bit of time. When we are executing a function, we pass a callback function to that. That means I will pass you this function. Whenever the operation inside the function completes, execute my callback function. So here you can see we have added this function with error and data, and this will execute after the fs.read file, this particular function completes. Main thing about asynchronous code is whenever the long waiting code executes, after that I want to execute a certain piece of code. So that certain piece of code, I give it by a callback function. We pass a callback function as an argument, and that function executes after the main function finishes execution, or anywhere in between if you want. But there was a problem. with this callback based approach. If I have multiple pieces of code lined up one after the other, I have to pass in multiple callback functions to each other. So that's called a callback hell, and that was very hard to read the code as well as very hard to debug as well. And in a lot of code bases right now, you would not see a lot of callback based functions. You would see more of promises. That's where we'll come up next. Promises were introduced in JavaScript much later. In a promise based approach, the function itself returns a promise, and we define what will happen when the promise gets fulfilled or if the promise gets rejected. So in that cases, if this fetch happens successfully in our case, then it will take the return value from the fetch, and then it will convert into another promise response.json, and then after that we will log the data whatever I got from the JSON. And if there is any error that happens in between, the catch will handle that. So it is much easier to read than the callback based approach, much easier to write as well. Another way of writing an asynchronous pattern is async await. Async await is also a promise based approach. So what this does is we wait for this particular piece of code to finish. We await this. So when we wait for this, and then when this finishes, then we execute the next line. And then wherever we are awaiting for it, that's a promise. The next line will execute only when the await finishes. One thing about using await is you have to use it in an async function. Async makes the function itself a promise. Await can only be used inside a async function. And to add the same functionality as before, so we had a .catch as well. So any error that happened would go into the catch block. We also can add a try catch and then log any errors that happened. Because await does not handle errors directly, we have to wrap it in a try catch. It's a more synchronous looking way of writing asynchronous code. In this case, response will wait for this fetch to complete, and then when the fetch completes, the data will await the response.json. When this finishes, then only other lines get executed. Then any errors go into the catch block. Strict mode is like JavaScript's way of saying, hey, let's stop being sloppy. We can enable it by adding a useStrict string on top of the file or a function. It helps in catching common mistakes, also prevents the use of undeclared variables. If we want to handle any errors, we can use the try, catch, and finally. Any piece of code that you think can create any errors, you wrap it inside a try block. And any errors that happen here would go into the catch block. So we can gracefully exit the program. And finally, we use, if you want to run a piece of code that runs no matter what, like closing of a database or rollback changes of a database and so on. It helps avoid crashing the program so that you can gracefully exit the code. You can use these tools in order to make your code better, more cleaner, and error resistant. Here's how you can use useStrict. On top of file, if I say useStrict, the whole file will run on strict mode. And if you want it just on a function, you can add it on the first line of a function. The try catch block, add a risky code inside the try. Any errors that happen here in the try block would come here, and you can log out the error, or if you want to do something else, you can do that as well. And finally will run no matter what, any cleanup required that it can handle. Some of the anti-patterns to avoid. Let and cons are more modern than where. That's why we want to use let and cons wherever possible. Where can sometimes give you certain edge cases that you would not expect where would give you that. So better to use let and const wherever possible. Try to use const at the most. Any objects that you did not create, you should not try to modify it, because that might cause certain errors internally in that object. You might not be able to predict the behavior. Try to use promises instead of callback. And whenever you are using certain external things that could cause an error, put it in a try catch block. If you use empty catch blocks, then any errors that you face would not be shown on the console, and then it would be a very hard time to debug it. Overuse of global variables should be avoided because it pollutes the global scope. Then it gets hard to understand what variables that you actually intended to use. Here are the key takeaways from this lecture. We have let, const, and where, the ways to declare variables, understand the scope. The hoisting rules will come up later, and reassignment and redeclaration. Arrow functions is a concise way to declare functions, and the this inside an arrow function is different from the this inside a normal function. Primitives and objects have differences with respect to the reference behavior. Primitives are passed as values and objects are passed as references. Object can have multiple properties in it. We looked at async patterns, how to use promise using the dot then dot catch, how to use async await. Strict mode and error handling encourages safer and more reliable code. We can handle errors using the try catch block and then gracefully handle the errors, avoid crashes, and make the code more resilient. Stricter mode is always better. Try to use it as much as possible. Takes out certain guesswork from the JavaScript code. It makes your code more reliable. That's it for this lecture. See you in the next one.